Hello everyone. In this video we will talk about the last principle from solid principle, which is dependency inversion principle, known as DIP. The dependency inversion is the fifth and last final principle of solid principle, and it plays a critical role in achieving loose coupling and flexible architecture. What mean by loose coupling? It means the components don't depend on each other, which is the best practice in coding. Dependency inversion principle say high-level modules shouldn't depend directly on the low-level modules. What to do? Both should depend on a layer of abstraction between them. Both call each other from this abstraction layer. Abstractions shouldn't depend on details. Details should depend on abstraction. Let's break it down. In traditional code, the high-level modules which contain business logic in our code often directly depend on the low-level modules like what? Like database, APIs, or file systems. Okay? What is the problem with that? This creates tight coupling. Tight coupling means the components depend on each other, making the system hard to change, test, or extend. Why? Because if the component tight coupling, which means depend on each other, this will lead, if you need to change something, it will affect on another part. Okay, so you can't change or test or extend easily. It will be hard for you to do that. Dependency inversion principle flips this dependency direction. It says simply high-level and low-level modules should both depend on interfaces or abstract classes. Concrete implementation, which are the details, should be injected into the system from the outside, often using techniques like constructor injection, factories, or dependency injection frameworks. What is the benefit of dependency inversion if I apply it in my code? First, easier unit testing, mock dependencies very easily, okay? More flexible, pluggable architecture, better separation of concern because you separate everything, not tight coupling. You make them decoupled from each other. Scalable and maintainable code base. Let's deep dive as usual in a use cases. Here I have a class called bank, okay? Contain a method, give customer money. The bank need to give the customer money. The customer have some money in the bank, and the bank or the user need to got back his money from the bank. Okay? If I have a customer class, okay, this customer class, I create object from the bank class here inside that class. Okay, I take object from bank class and its name my bank. Okay, the user, the customer need to withdraw his money from the bank. So what we made, I take my bank object dot give customer money. I use the function exist here in this class. So right now this class high level module bank depend directly on low level module customer. They don't call each other with a layer of abstraction. So this class violates the dependency inversion principle. How to fix this? Because right now the customer is dependent directly on the bank. How to apply it? Apply the dependency inversion principle. I will create an interface. This will be a layer of abstraction between the customer and the bank, and we'll call each other via this abstraction layer. I create interface ATM. The customer and the bank will call each other and can communicate with each other through ATM operation. Okay, so this interface contains function, its name ATM operation. Right now I create a class bank, implement this interface, and the class customer, okay, implement the same interface. In the bank class, I will override the ATM operation and handle what I need here. Also, in customer, I implement ATM operation, okay, and can handle the code that withdraw money from ATM and decrease the ATM balance from the specific user. So, simply, dependency inversion say high-level module shouldn't import anything from low-level modules. Both should depend on abstraction for use case or, for example, interfaces like what we made here. Okay? What is the problem with that? Imagine taking a 1-minute walk to the bank every time you had to withdraw a money. Okay? Every time you need a money, you must go to the bank, okay, over the counter. It then takes an extra 30 seconds for you to get your money. This is quite efficient because very little time is wasted. We will assume you are the high level module as a customer, okay, and the bank is the low level module. But what happens when the bank is closed for a holiday or an emergency? So in this case, you have absolutely no access to your funds, okay? If you move further away from the bank, it becomes a bigger problem because you had spent more time getting there. So to solve this problem, an interface is introduced, an automated teller machine, ATM, or a mobile banking application. Even though you have a relationship with the bank, you are no longer required to interact with them physically to be served, which makes sense. This example is similar to the dependency inversion principle. We should make our classes rely on properties in our interfaces instead of relying on each other or dependent on each other. Got it? The implications of violating this principle would result in a rigid system where testing blocks of code independently would be very difficult. Reusability of the code would be near impossible, and the addition or removal of code would lead to further complexity of the system and introduce bugs. This is a clear explanation for the last and final principle from solid principle. We must apply all these principles to have the best practice of coding. Thanks for watching and see you next video.